Welcome to Explosive Debris Examinations. This is the second topic of Module 6. We will begin by defining explosive and also explosion. We will then discuss the differences between low explosives and high explosives, and also list the common low and high explosive chemicals that are seen in forensic examinations. We will also discuss the methods of collection and storage for explosive debris, and finally, the various laboratory techniques that are used in explosive examinations. If we start by initially defining explosive, an explosive is a chemical substance or a mixture capable of producing an explosion. So exactly what is an explosion? This is a rapid change in energy resulting from a chemical or physical action that produces heat and gas. When we have an explosion, there are typically three different actions that can occur, either blast pressure, fragmentation, or thermal, and in most instances all three of these will occur. The first is blast pressure effects. This is caused by the expanding gases which are going to travel equal in all directions. The gas wave is going to shatter objects as it moves away from the origin, but this is also going to create a vacuum, which is then going to have a negative pressure effect. Most of the damage, however, is going to occur during that positive movement. There may also be fragmentation effects that occur. This is going to be because the explosion is going to shatter different things, causing pieces to be propelled with that gas wave itself. In a lot of instances, nails or shrapnel are going to be in the explosive device, so these may be part of the fragmentation that is getting propelled. There are also going to be thermal effects to occur. This is the extreme heat or fire that's produced at the onset of the explosion. Depending on if it is a high explosive or low explosive that is used, with a high explosive, that heat and fire is going to be very hot and very quick. However, with a low explosive, it's not going to be quite as hot, or it won't last quite as long. Usually this initial onset of the flash is going to die very quickly unless there is the occasion where it has ignited other combustibles in the area. So if we think about the various characteristics of explosions, there are going to be four things that can be used to characterize an explosion. First of all, that it is a very rapid reaction. And this is one of the things that distinguishes explosions from combustion or from fires. There's also going to be a very rapid production of gases and a rapid production of heat. An explosion must also be able to be initiated when that reaction is desired. Most explosive materials are going to require some type of stimulus to start that liberation of energy. And it's from this response to the stimulus that provides the basic classification for explosives, whether or not it is typically a low explosive or if it is considered a high explosive. One of the things that can help classify whether it is a low or a high explosive is according to the rate of brisance or the combustion or burning of that chemical. Brisance is the shock or shattering power produced when the material explodes. Usually this is going to be associated with your high explosives. But we also have explosives, both high and low explosives, that will combust. So this is any type of exothermic oxidation reaction but it's not limited to burning, deflagration, or detonation. So then exactly what is deflagration and detonation? Your chemical reaction that propagates a flame front which occurs particle to particle. High
explosives are going to detonate. This is the decomposition by an exothermic reaction that produces a shock wave through an explosive. Once again, your explosives may also be categorized by their sensitivity. High explosives may be categorized into either primary explosives or secondary explosives. A primary explosive is going to be a material that can be initiated by a relatively small amount of heat or pressure, where secondary explosives are going to be materials that are relatively insensitive. So if we look at a graph of explosives overall and then divide this into our low explosives and our high explosives, you can once again see that there are going to be compounds considered low explosives that deflagrate, and then high explosives that detonate, that can be divided between primary explosives and secondary explosives. So once again, remind yourself that there are going to be explosives that are based on the type of initiation and the speed of decomposition, and that your high explosives are going to detonate and low explosives are going to deflagrate. So this means that your low explosives are going to burn rather than detonate. However, they're going to be very easily initiated. They do require some confinement to be effective, so the main legal use of low explosives is going to be as a propellant in ammunition. So common examples of your low explosives are going to be black powders, smokeless powders, and flash powders. High explosives are going to detonate, and this detonation is going to take place very violently because there is not the burning. Your high explosives are going to be very sensitive to heat or to shock, so the main legal uses of high explosives are going to be through mining, demolition, or various military applications. And once again, your high explosives are going to be divided into primary and secondary categories. Your primary categories are going to be used in detonators or to trigger larger charges of less sensitive secondary explosives. A small quantity is sufficient to initiate that larger charge of the less explosive material. These are some of the commonly found primary explosives. A secondary high explosive is going to be less sensitive than a primary explosive, and it's going to require a lot more energy to be initiated. Usually the secondary explosives are going to be used in larger quantities and also in explosive trains. They're going to be initiated by a smaller quantity of a primary explosive. And these are some of your common secondary explosives. Ammonium nitrates, and then there are 3 different categories of nitrate compounds, and then also mixed compositions. So this slide breaks down the 3 different nitrate compounds into nitroaromatics, nitroamines, and nitroesters, and list a lot of your common secondary high explosives. Keep in mind there are also the mixed compositions, which may be a combination of various explosives. So now that you know a little bit about the basics of explosives that can be used, let's discuss the recovery and the collection and the examination of this explosive debris. Initially, we want to talk about the detection of the debris itself. Usually, this is going to be from an extremely good visual search of the crime scene. Initially, you want to look for the seat of that explosion, so where that bomb was actually placed. And then you're going to also spread out from that area looking for other fragments. And these tiny fragments can give a lot of information about that bomb itself in addition to the explosive. So you have to be very careful and have a good visual search to find a lot of these extremely tiny fragments. The fragments themselves may hold residues from the explosive product itself, but it also may give you a lot of information about the container that that explosive was held in. It may also give you information about any type of concealing container that the bomb was placed in. In a lot of instances, this might be backpacks or gym bags. So keep in mind we want to look for a lot of the various residues and then also various fragments that can give you information about the containers, the concealing containers, and also any detonating devices that might have also been a portion of that bomb. In addition to a good visual search, sometimes a vapor trace analyzer is used. And this is a portable unit that uses headspace combined with a gas chromatograph to help identify explosive compounds. We also need to be concerned with the collection and the storage of explosive debris, since the actual explosive residues are going to be extremely small. So you can use some of the common methods in your collection using the most direct but the least intrusive method, usually picking either with tweezers or with gloved hands, sometimes swabbing, and then also there are Teflon wipes that can specifically be used for explosive debris collection. You want to always put your evidence in non-contaminating containers. So in most instances, bags are used, sometimes boxes, and also cans. Remember to always label that container appropriately, including the addition of any warnings or hazards that might be necessary. And then once again, remember to seal that package with tape to provide that security measure and also a way of identifying it once you put your initials across that seal. In most instances, since the residue is going to be so extremely small, a lot of the collection at crime scenes is going to be larger fragments of the containers or the containers that concealed the bomb, so the actual explosive residue may actually be recovered in the crime laboratory. Usually this is going to be performed with the aid of a stereo microscope, so that the small powdery substances can be identified, and also at times unexploded material. In a lot of instances where your low explosives were used, some of the material may not be completely consumed in that explosion. So there might be the possibility of finding particles of unexploded material. Once again, some of the fragments in the containers or the components that the containers were actually placed in might also be very small, so you might also want to use the stereo microscope to help identify and collect these portions for further analysis. So once we have isolated the explosive debris from any containers or concealing containers, we want to concentrate on that examination of the explosive debris to be able to identify a possible explosive that was used. So initially, we're going to be answering various questions about what type of explosive might have possibly been used. Then, if there are portions from a container that concealed the explosive and any concealing items for that container itself. Also, we'll be looking for the various contents of any other explosive devices. So the containers and the concealing containers and the explosive devices would be collected and then further analysis done on those specific items, depending on if they are metal, if they're plastic, if they're fibers, or whatever types of forensic evidence they might be. But if we concentrate specifically on that explosive residue, trying to identify the explosive compound, we're once again going to be working with the various physical properties of the sample and also the chemical properties of that sample itself. So we'll be looking at the specific color of the residue itself, then trying to determine the texture of it. A lot of your residues might be in powders or crystalline forms, but you also may have residues that could be liquid, gel, or plastic. We'll also work with different chemical properties, which include spot test. These are going to be used primarily as a preliminary examination, but it will help that analyst identify the possible explosive that's in that residue. There are three main reagents that are used as spot test for explosive residues. These are going to be simple color tests. So the residue would be put in a spot plate and then the reagent is added to that and provides a color reaction if there is the positive presence of the explosive residue. They might also perform microchemical tests. Usually these are going to be used to help identify various anions and cations present in that explosive residue, which is going to assist the forensic scientist in the identification of the explosive. These are microscopic tests that are used. You usually put a little bit of residue in the reagent itself, and then crystals will begin to form. Depending on if the crystals are the preferred crystals for the test, it may give the forensic scientist information as to what element is actually present in that residue. They will also conduct testing to determine the elemental composition from the various residues. This might be done on an X-ray fluorescence, or usually it's done with an SEM because of your sample size being so small, or in some instances an X-ray diffraction unit might also be used. An FTIR can also give very valuable information about the explosive that might be present. It can take very small amounts because there are FTIRs that have microscopic attachments to them. And you can see from this the data that is actually obtained is very different for your various explosives. Another instrument that we haven't talked about is an ion mobility spectrometer. And this can also be used to classify various explosive residues by use of a mass spectrometer. This instrument uses an ionization source which puts a charge on the particle,
And then this particle will be moved through the system by placing a similar charge near it to push it, or at the opposite end of the tube itself. This will attract the particle or push the particle until it reaches the detector. And from this instrument you might obtain data very similar to this, which will also give the analyst information to help them determine what type of explosive was actually used. An HPLC might also be used in the analysis of the explosive debris. This would have to be where the explosive residue is actually extracted and then injected into the HPLC. If you remember, this instrument uses liquids instead of gases to move that sample through the separating column. And then finally, a gas chromatograph with a mass spectrometer may also be used to help identify the presence of specific compounds in that explosive residue. Once again, you're going to obtain a chromatogram from the gas chromatograph, and then also the ionization charges for the specific peaks within that chromatograph obtained by the mass spectrometer detector. So combining a lot of these various techniques, the analyst may be able to reach one of two results. Either that the chemicals were not consistent with a common explosive compound, or that the chemicals identified in the residues were consistent with a specific explosive.